Solve the given inequality. Present your answer in interval notation. This is an example of a rational inequality. We have a rational expression on the left greater than a linear expression on the right. There are two basic approaches to this, and that's why I have this problem written down twice. Let me first demonstrate the overall basic approach, and that is to move everything to one side. So if I subtract the x and subtract the 6 from the left, I would write this 4x minus 60 divided by x minus 9. And then we have minus x minus 6. I want to make this into one fraction. This will be greater than 0. Let me move that over a little bit. There we go. To make this into one fraction, let me put a plus, and I need to multiply this fraction by a form of 1 in the form of x minus 9 over x minus 9. What this does, first off, multiplying by 1 does not change the value of this binomial expression, and thereby we get an equivalent inequality. It also gives us a common denominator so that we can add these two fractions together. So we would then have 4x minus 60 over x minus 9. Let's actually combine this whole thing into one fraction, since it is a common denominator. So the denominator is x minus 9. We would have, got to be careful distributing this, minus x squared plus 9x minus 6x and plus 54. All of this greater than 0. Okay, combining all of that, simplifying, we have negative x squared. 9x and 4x is 13x minus 6x is plus 7x. And negative 60 plus 54 is minus 6 all over x minus 9. This is still greater than 0. We can factor out the negative. X squared minus 7x plus 6 divided by x minus 9 greater than 0. We can then factor the trinomial in the numerator. This is x minus 7. Sorry, that's not right. X minus 6 times x minus 1. All this divided by x minus 9 greater than 0. Okay, there's a lot of work there. What this allows us to then to do is to check on a number line. First, putting the values 6 down. That would be a hollow dot because we can't equal 0. Anything in the numerator would make an equal 0 if we use the value that makes that factor 0, like 6. 1 is also essentially an x-intercept. It can't equal 0. Hollow dot. And 9, this is a divide by 0 error. Definitely don't include that. So we have potentially left 2 middles and a right, 4 intervals that could be part of our answer. We want to check, like at negative 10, or at 4, or at 7, or at positive 10. And we plug these values in and see if the result is greater than 0. Now the benefit of having moved everything to the left side in this inequality is the right side is 0. So we're comparing with 0. So if we get a positive number, we know that's greater than 0 and will be part of our answer. If when we plug in these values we get a negative number, then that would be less than 0 and not part of our answer. So plugging in negative 10, we have the first minus out in front. Then negative 10 minus 6 is negative. And negative 10 minus 1 is negative. Divided by negative 10 minus 9 is negative. Notice we have 4 negatives 4 negatives makes a positive. This region would evaluate to a positive number, meaning the graph is above the x-axis in this region. Similar analysis is used on each of the intervals. 4, we have a negative, 4 minus 6 is negative, 4 minus 1 is positive, 4 minus 9 is negative. 3 negatives makes a negative. This is multiplication or division, and so these are 2 negatives multiplied to make a positive divided by negative is a negative, etc. 7 negative, 7 minus 6 is positive, 7 minus 1 is positive, 7 minus 9 is negative. 2 negatives make a positive. And finally, positive 10, we have negative. Negative minus 6 is negative. 10 minus 6 is positive. What am I doing? 10 minus 1 is positive. 10 minus 9 is positive. 1 negative ends up being negative. All right, so all of this is put together. We want greater than 0. So we isolate all the stuff that gave us pluses, and we can get our final answer. There's the left interval from negative infinity to 1, soft bracket because of the hollow dot, because there's no equal sign, union, and then this right middle interval from 6 to 9. We can't include 6 because that would make it equal to 0, and we can't include 9 because that's not in the domain. This is the overall process. Move everything to the left, combine it into one fraction, factor it, find the values of the x-intercepts or vertical asymptotes, put on the number line, and then test the values and the number line and see what your final answer is. There's a lot going on there. So, a lot of students looked to find a way to speed this process up. One way that's scary is clearing fractions. Now, why is this scary? So you can clear fractions, but I don't know if x minus 9 is greater than or less than 0. I don't know. So I don't know if I should keep this sign or flip this sign. Because if you multiply by a positive, this sign stays the same. If you multiply by a negative, this sign should switch. And I don't know what x minus 9 is. So the safe thing to do is to drop the inequality. We are no longer solving the inequality. Instead, see, that would be minus 3x and minus 54. Is that right? 6 minus 9, negative 3. Yeah. Instead, we now are just solving for these values, the 1 and the 6. But we have to remember that whatever you multiply by was originally a domain problem. So when we go to test the number line, which we still need to do, we have to put 9 down as a hollow dot. We're getting rid of the fractions, making things look easier, but that would also be getting rid of a potential domain problem, which we know was part of our answer over here. So we don't want to do that. To reiterate, if you want to clear fractions, whatever you multiply by, make sure that what makes that value 0, like x equals 9, is put onto your number line, because that's a domain restriction. It should not be part of your answer. So cut it out of your potential answer. Now, having said that, you also lose the inequality, so it'll be harder to test. You can't test with the plus minus stuff that we did over here. Instead, we'll have to check the original inequality, and it takes a bit more work. That's okay. Now, having gotten rid of the fractions, this looks like it's going to be a little bit easier problem now. Let's move everything to the right. Subtracting the 4x would be minus 7x, and adding the 60 would be plus 6. This factors, x minus 6, x minus 1, giving us 6 and 1 as other values to test. And there's no equal sign in the original inequality, so we need to make sure these values that make it equal to 0 are not included in our answer. Hollow dots. Okay, I will pull out the same values. It doesn't really matter. Any number in this interval to the left of 1, including 0, maybe we should do 0 this time, is valid for testing this interval. Let's go in between. How about 3, and let's say do 8, and I still like 10 over there. Any number in between. And what we need to check is the original inequality. So this original inequality, this would be 4 times 0 minus 60 over 0 minus 9 greater than 0 plus 6. That's 60 over 9. Is that greater than 6? 54 over 9 is 6. So 60 over 9 is greater than 6. So this works. These numbers work. 3. Let's see if we can speed this up a little bit. 3 times 4, 12 minus 60, negative 48. Over 3 minus 9, negative 6. Is that greater than 3 plus 6, 9? 8. 6 times 8, 48. 8 greater than 9? No, it is not. Try 8. 8 times 4 is 32 minus 60, negative 28 over 8 minus 9, negative 1. That's 28. Is that greater than 8 plus 6 is 14? Yes, it is. Check. And 10. 40 minus 60, negative 20 over 10 minus 1 is 1. Is that greater than 10 plus 6, 16? No, that's definitely not. And again, we get the two intervals for our final answer of negative infinity to 1, soft bracket, union from 6 to 9, soft bracket. Same answer, different approach, less fractiony. That's why students like it. Where students get this wrong is they keep the greater than sign, and then things get messed up in their checks. Or they clear the fractions and forget to include that 9 should not be part of their answer. So this is an approach that I actually use because I think it's cleaner, but I know that when I reduce the fraction, I pull that value out and make sure that it's on the number line. And I know that it's no longer an inequality, it's an equal sign. So when I get the values, I have to test the original inequality to see if it works yes or no versus is it positive or negative, and we want positive. Different approaches for different folks, and just make sure that you understand one entirely and practice it before you maybe want to learn the other. Or just pick one and get good at it and don't think about the other at all. You don't want to mix these somehow combined together into something else. These two, if you do them these ways, are consistent approaches. All right, hope it helps.